friends, welcome to our channel CBSE Science Lovers. So we are with you, so students. In our previous video, we were discussing about the balancing of the chemical equations. So I told you that how the chemical equation be balanced and why the chemical equation be balanced. So to follow the law of mass conservation, chemical equation have to balance. So in earlier video, we have seen that how the general chemical equations be balanced, and now I am going to tell you that how the ionic equations be balanced. So my dear student, let's take some example of ionic equations, that how the ionic equations be balanced. I told you that in ionic equation, to balance we have to balance the number of particles as well as the charge towards the reactant side and product side in both of the sides. For example, this is the reactant side of this equation and this one is the product side of this equation. So this equation is not balanced till now. So my dear student, let's see, in this equation we have to balance the charge also with the number of particles of different elements. So see here, aluminium react with hydrogen ion, one positive ion. So aluminium reduced, aluminium ion formation takes place, Al plus 3, and hydrogen gas releases. So this equation is ionic equation. Here students see the one positive charge towards the reactant side, whereas here the three positive charge towards the product side. So we have to balance the charge also. So to balance the charge, what we have to do, my dear student, just see, we also have to balance the particles, hydrogen, hydrogen. So how we balance the particles? Let's see. To balance the particles, put 3 just with the hydro. So to maintain the hydrogen atom particles balance, put 6 towards the hydrogen ion side. So hydrogen atom will balance 6 and 6 positive charge now. But here there is 3 positive charge towards the product side. So to balance the charge, put 2 with the aluminium ion. So 2, 3 just 6 positive charge towards the product side and 6 positive charge towards the reactant side. So charge will balance, but still aluminium particles are not balanced. Here you are seeing the one aluminium atom, but here 2. So to make the balance in the aluminium atom, put the 2. So in that way, this equation be balanced, is an ionic equation. So my dear student, we have seen that in an ionic equation we have to balance the particles as well as the charge. Both we have to balance in an ionic equation. Let's see another example. Hydrogen peroxide react with the iodide ion. What happened? Hydroxide ion released and iodide ion reduced to form the iodine. So my dear student, this equation in front of you, the skeletal form of this equation in front of you, and we have to balance it. Now see how we balance this equation. Just see, one negative charge towards the reactant side and one negative charge towards the product side. So charge we balance, but there is no balance the particles. Here the 2 hydrogen particles, 2 oxygen particles. So to make the two hydrogen and two oxygen particles, we multiply 2 to the hydroxide ion towards the product side. And then to maintain the charge, here now the charge is 2 negative towards the product side. So to balance the charge, we also have to put 2 by the iodide ion. So here the charge also be balanced. 2 negative charge towards the reactant side. Here 2 negative charge towards the product side. Now see the particles. 2 hydrogen particles, 2 oxygen particles. 2 hydrogen particles, 2 oxygen particles towards the product side. So hydrogen and oxygen particles also be balanced towards the reactant and product side. Now see iodine particles, here 2 iodine particles towards the reactant side, here also the 2 iodine particles towards the product side. So in this way we balance the ionic equation. So my dear student, so in an ionic equation we have to balance the charge as well as the number of particles towards the reactant and product side to follow the reaction law of mass conservation. So that is the simple phenomena to balance an ionic equation. Now, my dear student, I would like to tell you about the type of chemical equations on the basis of the energy evolved or absorbed. So in earlier classes, in earlier video, we have discussed that in a chemical reaction, either energy be evolved or the energy be absorbed. So on the basis, the energy transaction, chemical reactions are of two types. So types of chemical equations. So my dear student, there are the two type of chemical equations on the basis of the energy transaction. The chemical equation during which energy evolved, that chemical equations are said to be exothermic chemical equations. So my dear students, the chemical change or the chemical reaction in which energy released, that all are said to be the exothermic chemical reactions. Any combination comes under the exothermic equations. For example, if you burn carbon, then carbon react to oxygen to form carbon dioxide. So during this reaction, energy evolved. How the energy evolved? We write the evolution of energy like that, with the product in the form of heat. So either energy liberate in the form of heat or energy liberate in the form of light during a chemical reaction. So we mention this energy in a chemical equations towards the product side with the positive sign with products. So my dear student, carbon react with oxygen to release carbon dioxide, and energy also evolved during this reaction. That's why this reaction is an exothermic reaction. Now see another example, when magnesium ribbon burns to form the magnesium oxide, during which also energy liberates. So this is also one example of the exothermic equations during which the energy evolved. My dear student, there are many phenomena in which energy released, like our respiration. During the respiration, what happened? Generally, the food in the form of glucose C6H12O6 oxidized to form carbon dioxide and water, and a great amount of energy liberate. We also show the energy like that with positive sign toward the product side delta E. That is also one representation of the energy liberation. My dear student, the chemical reactions during which energy be evolved or released are said to be the exothermic chemical reaction. Another type of chemical equation, my dear student, are the endothermic chemical equations. So, what are the endothermic chemical equations? The chemical equations during which we have to give energy to proceed the chemical equation reaction. That all reactions are said to be endothermic equations or endothermic reactions. For example, decomposition reactions. All decomposition reactions are said to be endothermic reactions in which to decompose substance we have to provide the energy. For example, if you want to decompose water, then we have to give the energy, hydrogen and oxygen released in that decomposition, and a great amount of energy released. So we represent this absorption of energy by putting a negative sign towards the product side or by putting a positive sign towards the reactant side like that. So this one is the decomposition of water. So the reaction in which we have to give the energy from the any external source, that's reactions are said to be the decomposition. So take another example of decomposition reaction, calcium carbonate, CaCO3. When you decompose the calcium carbonate, then after the decomposition we got calcium oxide plus carbon dioxide, and during this reaction we have to give energy. So we can write like that with the negative sign toward the product side, or we also can represent this chemical equation like that. So these are the endothermic equations or endothermic chemical reactions. My dear students, on the basis of the energy transition, reactions are of two types, exothermic and endothermic. And exothermic reactions are those reactions in which the energy evolved or released during a chemical change, like the respiration, like the composition of hydrogen and oxygen to release H2O, or any burning reaction. And endothermic reactions are those reactions in which we have to give energy to proceed the chemical reaction. So, in for example, the splitting of water, for the water splitting, we have to give the energy to the system. Like that, water molecule when decompose, it will give hydrogen and oxygen, and we have to give the energy as an external energy to the system, then only this reaction will proceed. So this reaction is an endothermic reaction. Like that, calcium carbonate, to decompose the calcium carbonate, we have to give the energy to the system, then the calcium carbonate decompose to give rise the calcium oxide and carbon dioxide. So all these are about the endothermic and exothermic reactions. Be with us, and in our further videos we will tell you about the different type of chemical reactions. So watch our channel CBSE Science Lovers. Thank you. Have a nice day.